Hello, my name is Lowell Vanderpool, and this channel is dedicated to IT students, IT professionals, and anyone who enjoys learning technical subjects. This series is going to be covering understanding and troubleshooting fiber optics. We're going to be focusing primarily on the local area network, the server room, the data center, and primarily anywhere the IT pro is responsible for fiber optics. Fiber optics is a critical skill today. Understanding and testing and troubleshooting fiber optic cables, assemblies, end-to-end connections is an important skill for the IT pro. Today, even if you were to go buy a patch cable, you have to know a lot about fiber optics, or otherwise you're going to have to send that cable back, or worse, damage something because you installed the wrong thing. In this series, we're going to cover the following types of fiber optic cables used in your local area networks and your data centers. We're going to look at connectors used in your local area network and data centers. We're going to look at fiber optic tips, which are very important. We're going to look at adapters. We're going to look at basic fiber hygiene. And then we're going to look at testing light loss in cables and connectors. There's a huge selection of fiber optic cables. Cables used in telecommunication, long haul situations. We're not going to focus on those type of cables. Broadband uses a lot of cables that we don't use in the local area network or data centers. So our focus will be cables, connectors, etc., primarily for the IT pro. The basics of fiber optic cable is basically a core, which is glass, very high quality glass, and this is where the light travels through. You're also going to have a substantial amount of what is known as cladding, and this is really protecting the core glass. You're going to have a variety, depending on the cables, of coatings and buffers and all kinds of other stuff to help protect the cable itself. That will vary depending on the cable. But those are the fundamental pieces of your fiber optic cable. Are very important in telecom and in broadband. Single mode fiber optics rule in both of these industries. They use very specialized cabling, connectors, and splicing. Last mile internet broadband use of fiber is growing, but it's mostly used for getting data to residential head-end points. As you hear more and more talk about fiber to the home, or FTTH, most of that will be single mode fiber. Some of that will be, as we mentioned already, to the head ends. Some will be lucky enough to get actual fiber to the house. That will be the best of the scenarios. There are two broad categories of fiber optic cable in the LAN and the data center. One is OS, optical single mode cable. The other one is OM, optical multi-mode. Notice on the single mode, it's 9 micrometer core, very tiny core. Now the multi-mode has a 50 micrometer core, much larger. But notice both of them have a cladding of 125 micrometers. So they're actually the same size. The core is the difference. So here's an example of multi-mode, two forms of multi-mode and one single mode. The top multi-mode is called multi-mode step index. It's an old style fiber optics that ran about 8 megabits per second. You can see at the input I've got digital signals. As I modulate those signals very slow, indicating by the first set of digital waveforms, I can get it through. You can see the green circle and the green check mark. But as I start modulating that light a little bit faster, a faster rate, you see it doesn't get through. And of course, the faster rate, it doesn't. So this was one of the early fiber optics. Then we moved to multi-mode graded index. Much better. We get that low modulation through with no trouble with the yellow check mark. The medium's modulation speed, we still get that signal through without too much trouble. At the high end, it begins to have problems. But notice single mode. We got a laser, not an LED, very small core, all 3 modulated rates we can get through with no trouble. And that's really the big takeaway of multi-mode and single mode. Remember, single mode fiber uses a very small core, 9 micrometers or microns. That small core allows a more effective transmission of light over a long distance and at a higher speed. Just to give you a perspective on how small the single mode fiber core is, which is 9 microns, you can compare it to things on the right. A diameter of a single human hair, 40 microns to 20 microns, or a human red blood cell, 5 microns to 10 microns. Kind of gives you a perspective of how small that single mode core is. Keep in mind the cladding around that 9 micrometer core is still 125 micrometers. When we talk about single mode fiber cables, we're talking about speed and distance. Keep in mind though, the cost for these cables, connectors, and systems are more expensive. Now the first optical single mode is called OS1. It's normally indoors and in data centers. It has a shorter distance, about 10 kilometers, higher attenuation. It's based on a 2002 standard. The second version was OS2. It's an outdoor long-haul telecommunication broadband, longer distances, about 200 kilometers, lower attenuation per every kilometer. It's a 2006 standard. Remember, you cannot connect OS1 and OS2 cables together. As we turn our attention to multi-mode fiber optic cables, there are 5 versions of multi-mode cable: OM1, OM2, OM3, OM4, and OM5. OM5 is the latest standard, but it really hasn't went anywhere, and I'll talk about it. So OM3 and OM4 are the major standards for today. OM1 is the oldest fiber standard for the multi-mode. It has an orange jacket. The core size is 62.5 micrometers. It has a data rate of about 1 gigabit per second, and it uses the 850 nanometer wavelength. It can go about 300 meters. In 1995, I was in a school that had fiber installed throughout the school. We used OS1 cable and we used ST connectors. And we were told then it would have a 30-year lifespan. Don't believe it when they tell you it's going to have a 30-year lifespan. It was obsolete in 15 years. Next generation of optical multi-mode was OM2. Same orange jacket color. For 1 gig, you could go up to 550 meters. For 10 gigs, you could do about 82 meters. OM3 is still a very popular multi-mode fiber optic cable. 1 gig goes up to 550 meters. 10 gigs can go up to 300 meters. OM4 is the most used today. It has distances for like 1 gig, 550 meters, 10 gig, 400 meters, 40 gig up to 150 meters, and 100 gig up to 150 meters. This is the go-to cable for most installations today. OM3 and 4 are both laser optimized multi-mode cable. They were developed to accommodate faster networks such as 10, 40, and 100 gigabits per second. Both are also designed for the 850 nanometer vertical cavity surface emitting lasers. And again, that helps with that distance and that speed. A variation of OM4 is called OM4 Plus, uses a jacket color of violet. So the connectors and jackets that are OM4 Plus are all violet in color. It's typically used in backbone cabling between telecommunication rooms and the data centers, or between main networking and storage area network switches. OM4 Plus has the ability to transmit 40 and 100 gigs out to 300 meters. Now, OM5 is the latest generation of fiber optic cable, and the idea here was that we were going to transmit a lot more data across this cable. You can see the picture. I've got 4 colors of light, and what we would do is take, say, 4 channels of 10 gig, and each channel of 10 gig Ethernet we would convert into a different color, indicated like blue, green, yellow, and red, and then multiplex that into a single color and send it down the wire. Problem has been the complexity of the transceivers and optics and electronics, the cost of putting out new cable in a data center or local area network. So although this technology promises improvement in bandwidth, it has not taken the industry by storm. It's based on shortwave division multiplexing. You can see here's a picture of a transceiver, QSFP28. We have 4 25 gigabit Ethernet channels coming into our electronics. It's then converted into different wavelengths of light indicated by the blue, the green, the red, and the yellow. yellow, and then sent out a 100 gig multiplex signal. And then again, you have the transmit and the receive side. These optical transceivers are out there. You can buy them. You can even purchase them to run on OM4 cable, not OM5. The problem is you have to put in new fiber optic cable, plus these new expensive electronics has slowed the implementation and adoption of OM5. This is the technology that has revolutionized data centers, and it's the MPO MTP connector cable transceiver revolution. So when we talk about MPO MPT, we're talking about cables, connectors, and transceivers. With all those components combined, it gives the engineer and network designer the ability to reduce transceivers, connectors, and fiber optic cables, and yet improve the density of Ethernet traffic and improve bandwidth. It can support 8 fibers, 12 fibers, and 24 fibers. You can see some of the interesting details about the connector. Okay, Mr. Vanderpool, why are you saying that going to MPO connectors and MTP connectors is revolutionary? Well, let me give you an example. I've got 2 switches here. Right now, they've got a 10 gig uplink between this switch and this other switch. And your boss comes to you and says, based on the customer demand and the application, we want to upgrade that from a 10 gig uplink to a 40 gig uplink. You say, okay, no problem. So I'm going to order 3 more additional 10 gig transceivers for this one, 3 additional transceivers for this one. Now I got 4 transceivers at 10 gig, 4 on this side. Now I'm going to have to get 8 connectors, 8 fibers to this switch, 8 connectors, 8 fibers to this switch. Just start counting the connectors and fibers and transceivers and your head's beginning to swim. Not only are you dealing with costs, but you're talking about troubleshooting, points of failure. Now, let's throw a patch panel in between them. Now we got 8 rear connectors on the patch panel, 8 front connectors, and you're starting to count all this and you're going, oh man, this is a headache and a nightmare. Let's see what MPO brings to this problem. So here I'm on fs.com, and you can see I've got an optical transceiver. It's 40 gigs, multi-mode, and it supports the MPO connector. $39. So here's the result. Switch on both sides. I've got a new transceiver that's 40 gig, uses an MPO connector with 12 fibers. Now, even with a patch bay, 2 patch bays, very doable. I can live with this all day. And I'm talking about very affordable costs. Very easy to go from 10 gig to 40 gig uplinks, minimal cables, very inexpensive transceivers. Why wouldn't you want to go this way? This is revolutionizing the data center. We will dedicate an entire video on MPO technology so that you can get a better understanding of what's going on in this particular cable structure system. So MPO and MTP connectors have keys, they have polarity, they can carry from 8 to 12 to 24 fibers. Now the MPO is an industry acronym for multiple fiber push-on. Again, we talked about how many fibers it can carry from 8 to 24. Now the MTP connector is a version of the MPO designed some engineering enhancement to improve optical and mechanical performance. They are compatible. You can take an MTP and MPO and they work fine together. Here we see the flexibility of MPO. Notice I've got a breakout cable. I've got an MPO connector on one end that's going to provide us a 40 gig transmission. It's going to use 8 of 12 fibers. 4 of those fibers will be transmit, 4 of those fibers will receive, and 4 of them will not be used at all. We're going to send that out to a breakout cable that is designed for either LC or SC connectors. So here's an example of just exactly what we showed. You got a transceiver with say 40 gig. That's going to be, we're going to use an MPO for that. Then we're going to do breakout cables into individual 10 gig transceivers. That kind of flexibility is what is making this technology just such a great benefit for the local area network and the data center. Here's an example of the high end of MPO and MTP connector cables and transceivers running at about 400 gigabits per second using the 12 type MPO connector, 4 100 gigabit transmit, 4 100 gigabit receive, cable length of over 500 meters using OM4 cable. Connectors play a pivotal role in getting light from one endpoint to another endpoint. Let's look at and identify major connectors that are important in today's enterprise, network, and data center. It's important to appreciate every one of these connectors are precision designed. They are designed to mate ends to ends to get the most amount of light from one point to another. They each have advantages and disadvantages, and let's look at each of them. The SC connector is a snap-in design that mates using a push-pull action. It has a spring-loaded ferrule. It has an excellent insertion loss. It's the second most common fiber connector, and it can be used for simplex and duplex applications. LC connector is the most popular connector. It uses a 1.25 millimeter ferrule size low insertion loss connector. The LC features a latch design that offers that pull-proof stability. Administrators love that feature. So here we have the LC and SC connector side by side. And you can see the SC is significantly larger than the LC. In applications where we need density, the LC is definitely preferred. We can put a lot more connectors in a small space. Notice with the SC how it flops around in the container. It's kind of loose, but once you plug it into a connector like this piece of network gear, I'm going to pull off the dust cover and insert it into its mate. You'll see it locks real tight. Notice no more slack, no more play. The other one still has a little bit of play in it, but once it's connected, it's a very solid connector. Here's some examples of duplex and simplex. This particular LC connector is simplex. It's not connected to another fiber optic connector or cable. The reason for the duplex is because most transceivers require a transmit and a receive fiber optic cable and connector. So it makes sense to collar them together or bind them together so that they plug in naturally. Now these collars that make them duplex are precise. They have them at a precise location from each other so that the LAN technician can just plug them into a transceiver or patch bay and they fit perfectly. The same thing for the LC connector. Now you can break them apart. Most manufacturers will allow you to gently pull these apart. You can usually take a gentle screwdriver and pop these apart so that you can use them independent of this duplex connector or this duplex collar. This LC connector has a small break in the plastic collar, and if you're real gentle with stretching the plastic, you can pop these out of their collar and use them independently. The next two connectors are the FC and ST connectors. These are not found abundantly in data centers, networks, etc. because they're pretty old, but they're often used in specialty situations such as handheld test equipment. FC screws in and locks in place, so it's liked in handheld optical test equipment. It's a favorite connector. The ST connector is a push, twist, and lock connector. So anytime you really need that secure connection, you'll often see these connectors. The MU connector has a very reduced footprint and is usually mainly in dense applications. The connector is square and employs a push-pull mating mechanism. It's popular in Japan and Asia. It's used for SONET, SDH, LAN, WDM, CATV, as well as ATM applications. CS connector. It's made by Senko and it's half the size of an LC connector. If you look at the graphic on your left, there's an LC connector to the right, and on the left is a CS connector. The CS connector is significantly smaller than the LS connector. Again, that high density, the use for high density lends itself to the CS connector. It's also designed for 200, 400 gig transceivers, so this makes it the next generation connector. The E2000 connector is not used often in a data center or a network except to bring telecommunication into the data center. It's a loved connector because it has a spring load shutter that from dust, dirt, and scratches, the ferrule of that connector is always protected by that spring-loaded shutter. It also has one of the lowest loss when connected with a mate. It has one of the lowest loss of light of any connector in the industry. So you would think by now that we have everything we need to know about fiber optic cables and connect. No, you don't. You've just begun. Almost all the connectors that we've talked about so far have a ferrule. You have the core that goes through this ceramic ferrule. The top of that ferrule is shaped a certain way so that when the two ferrules meet in a connector, optimum light passes through. Very little reflection back into the transmitter is done because that's going to cause distortion distortion. If they're misaligned, it's going to cause loss of light. Both of those are unwanted. 3 kinds of shaping. Sometimes it's called polishing type, but they are PC, they have UPC, and they have angled physical contact, or APC. You have to know what you're buying and what you're connecting, because if you connect the wrong one, if you take a cable that's got a ferrule with an APC shaped ferrule and you insert it into a connector that's UPC, you're going to damage something. So you've got to know what these shapes are and what these, in most cases, are called polishing types. So I'm over here on fs.com, and if you'll notice, you can choose fiber type, fiber count, and then here, connector type, and then polishing. Is it UPC to UPC polish type? Is it UPC and you're connecting to an APC connector? You've got to know this before you buy the wrong cable, or worse, damage something. When you buy the right polished type, right connector, and everything is right, you should get low loss and very little back reflection into the transmitter. That's going to cause distortion. So those are the reasons why you have to understand all these conditions. So what is polarity in regard to fiber optic cables? Well, it isn't about polar bears, and it's not about the North Pole. Optical transceivers have a transmit side and a receive side. If you look at my little optical transceiver inside my converter here, my media converter, you see that one side is totally dark. That's the sensor side of the optical transceiver. On the other side, you see a little purple light shining out. That's the transmit channel of the optical transceiver. Notice that transmitter is on the left as we face it. Here I have another optical transceiver inside my switch, and you'll notice the same thing. On the right side of the optical transceiver, it's dark. That's the receive channel, the sensor. On the left-hand side is that purple light that's coming out. That's the transmit side. I have to be able to connect cables so that my transmit side of my optical transceiver goes into the receive of the other optical transceiver. So there's polarity in cables. Now, most patch cords that you purchase are what known as A to B. They have the crossover built in. In patch cables for fiber optics, you have to get crossover fiber optic cables so that the transmit goes into the receive and the receive goes into the transmit. This is totally the opposite of twisted pair cables that we use in our network cards, which are typically straight cables. You have to have crossed over cables, A to B, and that's typically what they sell. So in most cases, you don't want A to A fiber patch cables, because unless you know what you're doing, your things are not going to work well. So we always want the transmit into the receive into the transmit. That is what polarity in cables is all about. Your typical duplex patch cable is going to be an AB type. So I'm going to demonstrate a AB patch cable that you would normally buy from a store. Remember, the 2 transceivers on the table are going to have the transmit on the left side, receive on the right. So if the patch cable is right, it should automatically connect the transmit on one side to the receive on the other. So to verify that this is correct, we're going to take the transmit side of the cable and plug it into a light source. So I'm going to plug that into a light source, and that would normally be plugged into the transmit side of the optical transceiver. It should, if the cable is correct, it should take that and put it into the receive side of the next optical transceiver, and you can see it is in the right position or polarity. So a technician can just plug those cables in and it's going to work.